Okay, finishing this up here, now we have part C that says B is equal to C. Well, the only way two things can be equal if they are absolutely identical. So in B, we have the numbers 3, 4, and 5. C also has 3, 4, and 5. Even though they're not in the same order, they are identical items. Neither one of them has anything else. Neither one of them has anything less. So they are actually identical to each other. So this is a true statement. Now Part D says that we have C equal to D. Well, in that case, C is the elements 5, 4, and 3. D is the elements 3, 4, 5, and 6. These are not identical sets because we have an extra element in D that we don't have in C. So this is false. Part E says that B is a proper subset of C. That means that it is truly a smaller part of C. It cannot be equal to. So here we have B, that is the numbers 3, 4, and 5. Is B a smaller portion of C without being equal to? In this case, that's not true. They are actually equal sets. So this is false. Part F, I'm going to have to move down here, says the empty set is a subset of C. Well, do you remember whenever we were talking earlier and we said the empty set is a subset of every set? That is always true. Every single one. Okay, part G says the set 1, 2, 3 is a subset of A. So here we have A. If we were to take this part out, 1, 2, and 3, would that be a smaller portion of A? Yes, it is. So that is true. Let me erase some of this off again. Now, part H says 3 is an element of C. Now remember, an element is an item inside the set. So here we have our set C, and 3 is actually an item inside that set. So this is a true statement. For the next one, we have the empty set is an element of A. Well, remember when I said the empty set was a subset of everything? The empty set is a set. It is not an element. And you can never ever call a set an element. They are two different things. So this is a false statement. Now part J here says 4 is a subset or equal to B. Well, if we look at B, 4 is inside there. But 4 is an element. It's an item inside there. So it cannot be a subset. This is a false statement. Now, what would be a true statement here? If we had had this notation that said the set that includes the number 4 is a subset of B, then that would be a true statement. We have to understand the difference between sets and elements. Sets are subsets. Items are elements, and we can't mix the two. Now, for the next to the last one here, we have C is a proper subset of D. Well, in order for that to be true, remember all of the things in C have to be a smaller portion of D. And that is true in this case. We could separate out these items and they would be a smaller portion. So that is true. For the last one, we have this notation, which means the empty set is a subset of A. Well, these two here are virtually saying the same thing. Whether we use the notation with the circle with the line through it, or whether we use the notation that is the braces that have nothing inside them, they are identical. This means a set with no members is a subset of A, and the empty set is a subset of everything.